Okay, everyone, I'm going to go through some of the short response questions from the chemistry midterm. You can feel free to watch this in order or skip ahead to the questions that you need. Although if you struggled with any questions, it might be a good idea to listen to them even if you got them correct so that you can hear an explanation. When we're doing the short constructed response, the biggest thing you need to remember is that it's important to know what the question is asking, especially if they say this, in terms of. This is one of the most important parts of the short constructed response, because if you don't answer it in that manner, there's a good chance that you're going to get it incorrect. So let's focus ourselves on the words in our questions, noticing if it says in terms of, and let's talk through these problems. Okay, so we will start with question 51. They're based on the diagram of our bright line spectra, where it gives us 3 different elements and a mixture. 51 says, in terms of, important, both electrons and energy, how the bright line spectrum is produced. Well, first we want to think the bright line spectrum, that just means light. So I want to know how to produce light. Well, to produce light, they say, well, in terms of electrons, and electrons are what's important. What happens is the electrons become excited. They jump up to the excited state by absorbing energy, but that is not where I make the light. The light doesn't happen until I fall back down to the ground, releasing my energy. So it depends how you want to word it. You can say the whole thing, or you can focus on the electrons releasing energy. I'll write it as if we're writing the whole thing. So electrons become excited and absorb energy. Then energy is released as electrons return to the ground state. Focusing on, I use the words electrons, and I talked about them releasing energy. I answered the question in terms of both of those things. I'm going to get the answer correct. Focus on that it has to be when they release that energy. 52 wants us to identify all the elements in the mixture. Remember that I can do that by lining up and seeing what lines match. I can immediately see that cadmium is not going to be in the mixture. And that's because I can see right here. I first start out. If I look in my mixture, it's not there. So if it's not there, it can't be in the mixture. Then I would check out strontium and lithium. So if I look, strontium, I can cover every line which means strontium is definitely in it. Now I'm going to check out lithium. Try to draw straight lines here, but you never know. And all of those lines are covered, so lithium is in it. So the answer for all of the elements in the mixture, lithium and strontium. You can write out the names, or you may write their symbols as well. Moving on to question 53. It gives us a table. Let's read the top. 3 elements are represented by D, E, and Q and are located on period 3. Some properties of these elements are listed on the table below. A student's experimental result, that may be important, indicated that the density of the element is 2.1 grams per centimeter cubed at room temperature and standard pressure. This may be important. I'm going to underline it to come back later. Then I see I have properties, 3 different elements. It says identify the physical property, focus on physical, in the table that could be used to differentiate the samples. Differentiate meaning tell them apart. So if I'm going to tell these apart from each other, I look. Phase would be physical. They're all solid. Mass, physical. They all have the same mass. But I do notice right here, my density is changing. Density is a physical property that is specific to an element. So the answer to 53, density. Some people on the test put oxide formula. It is not oxide formula. This would be a chemical property because that is when they actually react and form something new. 54. Identify the group on the periodic table to which element D belongs. So I'm going to look up here. I'm looking at element D, and phase is not going to really help me. It's solid. Lots of things are solid. Mass isn't going to help me. That density, it could help me, but not really because I don't know exactly what element D is. But the oxide formula where I see D2O, that's what's going to be important. If I know it is D2O, remember our bonding in our periodic table. I can reverse my crisscross, meaning the 2 goes back to the O, so O must be minus 2. There's nothing by the O, so it's really a 1. I reverse that. That goes to D, so that must be plus 1. I'm going to focus on that plus 1. Plus 1 means I must be in group 1. And there is no other group that would fit that bill. On the test, on the answer sheet, it did say that it wanted the period, so I did accept if you put period 3 from the answer, but this is what we're focusing on, so make sure you're able to do this. 55 says determine the percent error between the student's experimental density and the accepted density of element Q. It's going to be important that I know where percent error is, and if I look, reference table, percent error, right there, measured minus accepted over accepted times 100. So I got to figure out who is measured. Well, let's go back up here. It said a student's experimental result. Experimental result means it is measured. So this must be the measured value. So I'm going to say, okay, my percent error equals measured is 2.10. Accepted value, I'm going to my table, 2.00 over the accepted value, 2.00. And I can't forget that it is also times 100, and that is going to give me 5%. Exactly 5%. You did not need to show your work on your answer sheet. When you're explaining it, you do. You just needed to show that answer right there. 56. A student drew the Lewis dot diagram below to represent sodium chloride. Right there. Explain why this diagram is not an accurate representation for the bonding in NaCl. Let this be your clue. Bonding. Well, you should decide. Am I ionic? Am I covalent? Like I keep saying, you must decide that first before you move on with anything talking about bonding. If I think about NaCl, Na is a metal, Cl is a non-metal, which means I'm ionic. That is important. If I'm ionic, I want to think, do I share or do I transfer? Ionic transfers. When I look at this diagram, this is not a transfer of electrons. By drawing dots, remember that 2 dots are equal to a line, so it would also look like this. When I look here, there is a couple problems. One, Na does not have enough electrons. That's right. But you want to focus on the fact that this would mean sharing. If I put electrons in between, they are sharing. So for this question, I want to tell them that the answer, I am ionic, and it transfers electrons. Instead, you have to compare it, of sharing. Or you could say that it's ionic, it transfers the electrons, or it doesn't share because the other thing is drawn as covalent. That would be okay as well, but you want to focus on that. Ionic doesn't look like this. I could also describe, as long as I said it was ionic, I had to say that. I could also tell them, which some of you did, that I should really draw it this way. Na plus 1 plus Cl, I'm going to put 8 dots in brackets and a minus 1. Some of you described that, but you really had to say ionic. Focus there. 57. Compare the mass of a proton to the mass of an electron. Well, mass. Focus on mass. Protons and electrons. This should be something that you definitely know. We can guarantee that there will be multiple questions on this on the Regents. Probably one of the first 5 questions will be this. And the mass of the proton I want to know is 1 AMU. The mass of an electron is 0 AMU. I did allow you to say that a proton is greater mass than an electron, but I'd really rather that you say this specifically. Proton 1 AMU, 0 AMU for my electron. A lot of people on this question wanted to say that the proton is plus 1 and an electron is minus 1. Well, yeah, that is very true, but these are your charges. Charge, not your mass. So you want to focus on that I wanted mass. Moving on to question 58. Testing of an unknown solid shows that it has properties listed below. Low melting point, nearly insoluble in water, a non-conductor of electricity, and relatively soft solid. State the type of bonding that would be expected, so type of bonding that would be expected in the particles of the substance. I want to say, is this ionic or it's covalent? Well, because of all these things, these are covalent. If you wanted to decide between polar and nonpolar, technically because of this, then nearly insoluble in water. Water is polar. So other things that are polar will dissolve in it. So technically this would be not only covalent, but it would be non-polar covalent. You did not have to say that though. Covalent is the main thing here. You could have also worded covalent by its other name. Remember that covalent is the same as, so I'll say AKA molecular bonding. Focusing on, again, low melting point. It's a non-conductor, and it's a pretty soft solid. Ionics will be pretty brittle. 59, explain in terms of attractions between the particles why the unknown solid has a low melting point. If you have no idea, you've got a 50-50 choice. You do need to word it as attractions. So it's either strong attractions or weak attractions. Because it's covalent, it is weak attractions. You do have another option that I did accept. I did accept if you said weak IMF, because intermolecular forces, attractions are a measure of the intermolecular forces. I'd prefer that you use attractions as the word because it said in terms of that. But weak or strong or high or low is how you always want to answer these. In this particular case, because it's covalent, I have weak attractions. Now 60 said in your answer booklet, I'm just going to do it right here. First, I want to do calcium chloride. Again, before you do anything, decide if this is ionic or covalent. This is ionic. It is a metal and a non-metal. So if I'm ionic, I must crisscross first. I should look up that calcium is +2. I should look up that chlorine is -1. Then I crisscross them. That means I would get my formula to be CaCl2. That 2 is important. I have 2 chlorines. So a lot of people got this question almost right, but they forgot to include the 2. So if I was going to draw this, oh, my lights went off here. Hold on. I hate the motion sensor. If I'm going to draw this, I'm going to take, if I'm ionic, I take the first thing, I write it, and I put the charge. I then put a plus sign. I take my second thing, I draw it in brackets with 8 dots, always 8 dots. And I always put the charge, -1. Now I'm almost there. I just have to remember that I had 2 of these, so I have to say I had 2 of them. Or you may redraw another chlorine. There's your answer to 60A. 60B, carbon dioxide. I see that I have a non-metal and a non-metal. I also see this di, this prefix. Prefixes are only used in covalent compounds. So B, I'd say, is covalent. And since I'm covalent, I'm going to share my electrons. So carbon dioxide is CO2. If I add up the number of valence electrons that I have, I'd say carbon has 4 valence electrons. Oxygen has 6, but I have 2 oxygens. That's going to give me a total of 16 electrons that I have to distribute. So my drawing is going to end up looking with C in the middle. You would put the O's on either side. And you would start putting on your electrons. But if I did that, I would notice 2, 4, 6, 8, 10, 12, 14, 16. I've used my electrons. That C is not happy. So if the C is not happy, I've got to move electrons in. So I'm going to try to grab some electrons here, move them right in. So this is not the answer. I'm going to go with C in the middle, double bond to the O, double bond to that other O, put your remaining electrons on. Recount. Do I have 16? 2, 4, 6, 8, 10, 12, 14, 16. Is everybody happy? Happy, happy, happy. Everybody's got 8 electrons around them. So this is your drawing for CO2. Questions 61 and 62 are based on this information. It says metal M, okay, it's a metal, was obtained from a compound in a rock sample. Experiments have determined that the element is a member of group 2 on the periodic table of elements. 61. What is the phase of the element M at STP? Well, the phase means, tell me, is it solid, liquid, or gas? Solid, liquid, or gas? Well, we said it was a metal, right? Metals, we know, are solids. So the answer to 61 is solid. Again, because it's a metal. 62, explain up in terms of electrons. Why, so why is element M a good conductor of electricity? Well, a lot of you wanted to tell me that M was a metal. That's true. So why do metals conduct electricity? Well, it's because of their electrons. Element M is what we're talking about. So element M has mobile electrons. I've now used that word electron, that's important, and I've said why. It's mobile. They move. I don't care if you say the electrons move. I don't care if you say it's a sea of electrons. I don't care if you word it like this, mobile electrons. But every time they ask you about a metal and why does it conduct, that's your answer, mobile electrons. I'm going to do 2 more in this video, and then I'm going to stop here and then restart another video for you. So we start here, 63 and 64 are based on this table. So 63 says, which electron configuration represents an excited state, okay, it's excited, of a calcium atom. And I'm looking right here at my electron configurations. What I would do if I were you is go to my reference table. Let's find calcium. Let's see what its regular, not excited electron configuration would be. So if I do that, I got calcium right here. Hopefully you can see that it says 2882. Oops, I'm pointing to the wrong one, but 2882. So if I look over here, 2882, this is regular Ca, or in the ground state. So, yeah, that's not going to be the answer. So if I'm excited, I have to have the same number of electrons, but the electrons move. So I want to look for someone where the electron is moved. If I look at Z, it says 288. I've somehow lost 2 electrons. That's not going to be it. So it must be here, 2873. If I total those up, those are still going to add up to 20. But if you see here, one has moved from here, and it jumped into that one. So the answer to 63 is configuration Y. Or you could have written out the configuration here. 64 says, what is the total number of valence electrons in an atom of element X? I remember valence electrons are the electrons in the outer shell. So all I want to do is go up here. They were asking about element X again, so go up here. Last number is a 2, so the answer is 2. Hopefully those has helped you, and if you have questions on 65 through the rest, look for the second video. Thanks.